Well, folks, we got back to beautiful, gorgeous summer weather. Up here in the mountains, we have, in my opinion, the best summer weather there is when it's normal. It's normal now. I guess the weather gods heard my complaints last time and fixed the problem. It's beautiful. The day has been cool, low humidity. It couldn't have gotten more than maybe 75 degrees at noon. It's about 60 something now. And it's just a gorgeous summer evening. Charging my truck. Anyway, because we're having such a beautiful evening, we're gonna use the evening sunlight to film this episode of the Paradox test set. Okay, folks, I didn't get the camera set up before the sun set below the tree line. So what this video is going to be about is the Paradox 2 armature assemblies. And what we see here, this is the Paradox 2 brush assembly. And there's little channels built in. One has a blue wire, a wire wrap size wire. The other one has a yellow wire wrap size wire to keep in conforming to our yellow-blue color scheme here. And the wire wrap wire, let's see if I can bring it up real close to the camera, is just soldered right to the edge of a little copper tube. This copper tube has got a 2 millimeter inside diameter and a 3 millimeter outside diameter. And the yellow wire is doing the same thing to the other side. Now the reason for these tubes is because we're going to use 2 millimeter pencil lead to act as our brushes. And the rest of this housing here, if you can see in the camera, I don't know, is a plunger and a spring assembly. And that plunger and spring assembly helps push the brush up against what will be the ring. So this brush assembly is going to end up right here with the brush assemblies up against the face of the copper ring. Okay, opposing this is going to be the magnet holder. And the brush assemblies are going to bisect the magnets, or at least the wires that go to the brush assemblies will. This is the Paradox 2 configuration. So this is the magnet holder, this is the brush assembly. The reason why I made these separately is so I can swap out or even change to a different magnet size and not have to keep building the brush assembly for every stinking armature that I make. So I'm going to reuse the same brush assembly and just either dial in different magnets or build a completely new different magnet holder with different size magnets. And the way this is going to look when it's together is this will be on the armature, and we're going to connect the blue and yellow wires together. And then on the armature, the magnet holder is going to sit with the magnets flush or in parallel, and this is going to be on top, bisecting a magnet and making contact with the brush, with the ring. The brush assemblies will make a contact with the rings. And this will rotate that way. And then the voltage that is generated will be picked up by these wires, sent along to our brushes over here, and these are going to transmit the energy out to a microvolt sensitive instrument. So that's where I got some more things to do. I've got to put holes in these things so I can put a 440 screw through the shaft to prevent these from spinning. Same with the blue. All the blue components need that, and there's some other things I have to do before I can finally put this thing together, but it's quite possible we might make our first measurements tomorrow, which would be Sunday. All right, folks, this is day 2 of the Paradox 2 armature build. And so I was hoping to get to measurements today, but it looks like storms are rolling in, and I'm running out of time. So that's going to be it for this weekend. So let me show you where we ended up. I put in the screws in the blue parts that'll help prevent the blue parts from spinning on the brass shaft. I also reduced the shaft length to 6 inches. That's good because it gives me another 6-inch shaft to do something with. I connected the blue and white wires of the brush assembly to the blue and white wires that for this brush assembly to this brush assembly. So now the blue and white wires from this assembly are connected to the blue and white wires of that assembly. They are soldered and they're with electrical tape, and then they're held down to the shaft with this ugly looking blue tape here. The next thing that is the brushes are in, the 2mm pencil leads, which are acting as the brushes against the ring, have been inserted. And we can see that because if I slide the assembly back, you can see these little plungers depress, and you can see the leads come out over here. Now they're no longer making contact with the outer ring. So if we push the assembly back in, you can see they're making contact with the outer ring. So those brushes are installed. The only other big thing we had to do today is, because I moved this ring from the other side to this side, I had to drill out the holes in the wood larger so that I could slightly move to properly center the ring holder. Other than that, the only thing that's left here from a mechanical standpoint is to put in the screws with the washers, and I'm thinking I'm not going to do that. I think I'm just going to put C-clamps to keep these guys from sliding back and forth. I think a big old honking C-clamp will probably be everything we need to do, and it's easy to remove and slide these things around, so I think I'm going to go that way. The only other thing mechanically, I think that's it mechanically before we can take the measurements. Oh yeah, let me show you from the back. You can see that the magnets are installed, and we are using the large magnet holes this time, and you can see I have a north facing out magnet here and a south facing out magnet here. What I do is I use Sharpie marker to color the faces of the magnets so you can keep track of which side is north and which side is south. And then later on, in order to change out the magnets, this is a pretty clever design here if I don't say so myself. All I have to do is loosen these screws. I don't have to take the armature off, and then this yellow assembly slides back, and then from this side I can change out the magnets, and then I can rotate that assembly so that now that these holes are over the brush assemblies. And then I can slide it back on and then put the screws back on, and that's the quick way of changing out the magnets for the Paradox 2. Now, when I want to put a new one of these in, obviously I have to take the whole shaft off to replace the yellow part, but that's pretty easy. All I have to do is remove this part and slide a new yellow shaft on, and it'll line up to the, because these screw holes here line up with the blue. Okay, but the blue has a screw that holds the entire kit and caboodle to the shaft to prevent it from slipping about the shaft. Okay, so the blue does all the anchoring, and that allows me to have the orange to be the replaceable, removable part, and that has made life a lot easier. So the only thing left to do on the electrical side is I need to put on the stepper motor controller, and I got to get a source for that. I don't know if I want to run it from a frequency source. I'm thinking I might just make a little Arduino and use that, because then I can make the Arduino slowly ramp up the speed to the proper speed and slowly ramp down, which is a lot nicer than the abrupt starts and stops. And the other thing we can do is we can have the Arduino command the Arduino to go to a certain speed, and then have automated equipment that'll take the measurement instead of me doing it manually. I don't know if I want to go through all that. That may not be necessary. And then the instrumentation here, I think I'm going to rebuild I already rebuilt the microvolt sensitive meter, but I got brand new instrumentation amps in that have a lot better performance than the ones I've been using. So I'm going to rebuild and that shouldn't take too long next weekend. So next weekend is very likely we'll be able to take the measurements of the Paradox 2 for at least 2 different sets of magnets. So that's where we are this weekend. Thank you for all being patient,